This is part 2 of creating the solitaire game Osmosis. So we're going to go over creating the deck of cards in this video. The first thing I had to do is download some card images. So I did a quick Google search and found some freeware card decks. This is the one that I downloaded from jfits.com. You get 50 some images. You get the full deck of playing cards, and then you also get the cards face down. And using a little bit of terminology, when they're face down, we actually call those a down card. Okay, so downloaded those and put them into a subdirectory called card images. And it's going to be important how those are labeled because we're going to be using those cards, card name or card file names in our program. So for example, if we want the 10 of clubs, we have to know that the image is called c10.png. So fortunately, they're labeled in a really coherent way. If you want the ace of clubs, it's C1. If you want the king of clubs, it's CK. If you wanted the jack of diamonds, it's diamonds, jack, DJ. So it's not too hard to figure out. All right. Now, to create the deck, I created 2 classes. Created a card class and a deck class. I'm going to go through and describe those. But before I do that, these are PNG files, and natively Tkinter does not deal with PNG files. It deals with GIF files, but not PNG. So to deal with PNG files, we have to download image TK, or actually PIL. So PIL is a package that you actually have to download. It's not built into Tkinter. You can do that through PyCharm. So go to File and Settings. And what we want here is, let's see, where is it? Interpreter? Yeah, and we're looking for a package. So we're looking for the package PIL. So we go over here and add it and do a search for PIL. And when you do a search for PIL, well, mine's already installed, so it's not going to find it. So that's not going to work for me. But you should be able to search for PIL in here and find it in your list and install it. So that's the way I did it. I got PIL installed, and then I can handle PNG files. Also importing iter tools, which I'll describe in a minute, and random, which is used to shuffle the deck. Okay, so for a card class, decided to build a card class simply because we have to store these images in memory when we display them in Tkinter on the canvas. So this is a feature or bug of Tkinter, depending on your point of view, that in order to display an image, you have to set a variable equal to the image TK version of that image, and you have to keep that in your program until you delete the image off from the screen. So if you don't store this image somehow in your program, it just won't display. So because I had to do that, I decided that for each card I would just create a class for it, and then I can store the image inside the class and keep everything kind of organized. So for the card class, we're passing in suit, rank, and an optional color. The color is optional because you only need to know the color for the down card. And so we will call this with a down card, but only once. Excuse me. We're passing in the suit and the rank. Now the suit in this case and the rank are going to come from a list. So the suits are going to be just the first letter from the suits. So spade, club, heart, diamond, and then the ranks are going to be ace through the king, with the ace being 1, and then 2 through jack, queen, king. So these are really just single character strings. And then if the color is none, if the color is none, that means that the card's going to be face up and we don't care what the color is. Then to get the card, we go to the image file location, which is just card images. So that is the directory they're stored in. this directory is inside of the same directory that the program is in. So there's card images, that's a subdirectory, and then here's the actual program we're going to be running. So to find the image, to get the image name for the card, it's that subdirectory plus, and slash to get us inside the directory, and then it's suit plus rank. So if we did SK, so if the suit was spade and the rank was king, then suit plus rank would be SK plus .png would give us sk.png, and there is the image for the king of spades. So keep in mind that when we're doing plus here, these are all on strings, so this is concatenation that's being done. Alright, so if we're actually passing in the color, so color is not none, that must mean that we are looking at a down card, and if the color is red, it turns out that the version you want is b2fv.png, and if otherwise the color is blue, you want b1fv.png. So that's the name of the images for the down cards. Once you have the image name, then we pass that in as a file to imagetk.photoimage, and that creates an image object. Again, we're going to store that image object so that it can be displayed on the canvas. Okay, since I'm going ahead to make a class for these cards, I decided to add a couple of methods to it. So there's a string method. The string method just concatenates the suit and a rank, just like was done up here. So again, if you pass in something like the 10 of spades, then suit plus rank would be S10. That's a handy way to get a tag for a card. So when we put this image up on the canvas, we're going to have a tag for it so we can then delete that image and move it easily. And then I also decided that since I was here, I might as well go ahead and define an equals for two cards. So remember that when you're doing something like equals, where there's two things being compared to each other, there's two built-in variables you can use, self and other, and these two will be equal if the two suits are equal and the two ranks are equal. Okay, now the deck class. The deck class has a couple of few class attributes: width, height, suits, and rank. The width of these cards is 71 pixels. The height is 96 pixels. So I just loaded that into a photo editor and checked that out. Got those numbers off. Then the suits are going to be spades, clubs, hearts, diamonds, and then here's the ranks, ace through king. And I made these based on the way that these images were named. So these came from these image names. Just makes it convenient to do it that way. The color is going to be passed into the deck, which we set here. And then here's where we use the iter tools. So remember up above, we loaded a package iter tools. Come back down here, which we do iter tools.product. Now what that means is a Cartesian product of the suits and the rank. So down here, I actually have instantiated a version of the deck, called it red, it doesn't matter if it's red or blue in this case, and printed out this list order. So this list is called order, and it's a list of this product of deck and suits. So what does that mean? Well, you take the first entry in this list, suits, and pair it with every entry from the rank list. So S1, you pair those two together, and product creates then an ordered pair for those two. Then you pair S with 2, you get another ordered pair, S with 3, another ordered pair, and you do that all the way down till you get to S king, which is right here. And then you start with clubs. So you pair the C with a 1, the C with a 2, and so on, until you get every possible combination of suit and rank, which gives you all 52 cards in the deck. Very handy. Then you turn that whole thing into a list. So this is a list of ordered pairs of suits and ranks. And this is how we're going to keep track of our cards. Those self.order actually become then keys for a dictionary of cards. So I commented this out because, well, I'll tell you why in a second. I'm going to create a dictionary of all the cards. So that's the deck. Deck is this dictionary. I created a down card. Now every card has an ordered pair, suit, rank, but for the down card it doesn't matter because, well, it's face down, you can't see the suit and rank. So I just call it down card, down card. I could have called it anything I wanted. That's what I chose to do. Now this for loop then goes through all the possible suits and ranks because this is a for loop through self.order. So this is a for loop through this list, but this list contains ordered pairs, and I know that, and the ordered pairs are again suit, rank. So for the ordered pairs in self.order, then deck, I add on to that dictionary a key value, suit, rank. So for spade 6, I create a card with that suit and rank, and remember that card not only holds the suit and rank, but it also holds an image for that card. So this is a dictionary then. Self.deck is a dictionary of all the cards in the deck along with their images, and not only the 52 cards in the deck, but I also add on a down card at the end. And what I pass in here actually doesn't matter. The fact that I'm passing in color, remember, up here, tells the init up here everything it needs to do. Okay. So what else do we have inside the deck? Inside the deck we have the ability to do a shuffle. Oh, and I had this commented out before. Remember that? Well, the reason why I had it commented out is because in the creation of this dictionary we call card, and card wants to create an image. But unless you're inside the Kinter window, you can't actually create those windows or those images. It'll complain and throw a bunch of errors if you try to do that. So when I'm actually just trying to show you how these methods work, I have to comment this section out. In the next video, we'll actually be making it to Kinter window, and we can leave these lines uncommented. But for right now, I want to show you how shuffle works. So shuffle just calls, remember we imported the package random? Well, random has in it a method called shuffle, and shuffle takes a list and then sorts that list, or randomizes that list in line. So what in line means in this case is it's not going to create a new list. It's going to take this list and just, well, shuffle it. So for example, we have red.order. Now red.order is always going to look like this initially. It's always going to be in this order that's down here. But then we can shuffle it. Notice that I can't print out red.shuffle because, again, the output of this is either going to be, yeah, I was able to do the shuffle, or no, I wasn't. So there is no output. It just takes the list that you give it, shuffles it, and that's it. It doesn't create a new list. So there's no output to print here. But what I can do is, after I'm done, print the same list red.order. So I start off with red.order, which is going to look like this, shuffle it, then reprint red.order, and notice that this list has the same name as that list, red.order, and that's what inline shuffling means. Okay, so the deck has a shuffle method, which just takes the list of 52 cards and puts them in a random order. And then the last thing we have in the deck is a change color method. The change color method does that. It just changes the color of the deck, and it does two things. It sets self.color to the new color. I'm running out of battery. I better get downstairs quick. And it takes the down card and creates a new one with that color. Okay, so that is then the card class. Notice that last piece of code there. If name equals main, hopefully you remember that from a previous video. That just is a piece of code that says if you're actually running this module, then that just checks to make sure you're running this module from inside the module. If I was calling this module from a different module, this name wouldn't be main. Remember, we covered this in a different video. Okay, that's it. Okay, so let's see. What more do we have? The card. Oh, we actually don't need this, so I don't even know why that's still in there. Apparently, I forgot to delete it, so just ignore that. There, deleted. Card selected. So when you click on here, then that's going to set the card selected. The position is where you clicked, and those are could be two different things. So you click on a card, like I click here, pretend I clicked here, and that selects a card, and then I click down here, that's going to be the position. So this could be two different things. I have a massive dictionary here of all of these rectangles. So each one of these rectangles has 4 corners, and to draw the rectangles you need to know the locations of those corners. And so I've got this big dictionary. So for the deck there's 4 corners, and those are listed right here. And then for the stack, that's this one, they're listed here, and so on. So for the kitty, come on, rows, and for the played rows. So every one of those rectangles, the 4 corners are listed in here, and it turns out these are also going to be tags for those places later on. The cheats, when you right click, puts cards up here. I only needed the centers for those because I'm not drawing rectangles, so that's another dictionary. And then we call new game and run main loop. Okay, so this video's got to be getting pretty long here. Let's run through what new game does. New game prints out those help messages. So there's a def to print out the help messages. We pass in the position, the message, the width that we want to play it in, and we also put it in, and then a tag so that we can delete it. And for the cheats, we actually want to be in the first one. So if it's different for the cheats because the cheats are given as centers and the rectangles are all given as corners of rectangles. For the cheats, we just take X and Y to be the cheat center of the first one. So for the other ones, we take the average of, for X, we take the average of the upper left and lower right corner, and we do the same thing for the right. We take the upper left and lower right corner and average them together, unless you're doing it in a play row. In the play row, if we took the average of the upper left and lower right, you'd be in here in the middle. I wanted it more to the left, so that's a special case for play row. For the X value, I just took the upper left of that. And then we create that text message, and we're going to call this print help message down here. Reinitializing self.played, self.kitty, and self.stack. So every time we get a new game, those have to be all initialized to empty because there's nothing in them yet. Nothing in the kitty until we actually deal the deck. It's going to happen below. Reinitialize card selected in position. Delete everything on the table in a new game. Then we create the rectangles based on the corners we had above. So we create a rectangle. This is the upper left corner, this is the lower right corner, and then we give it a tag that is the corner. So remember that the tags up here are deck, stack, K row 1, K row 2, and so on P row 1 through P row 4. I know this is going fast. There's a lot in here. Then we print those help messages, we tag them. Again, stack, deck, P row 1. So we're going to use these tags a lot. Double click here to deal with 3 cards. For the first one, we just use the pack width. So this gets the pack width. The one in the stack gets the pack width. And then these other 2 are twice as wide because there's more space for those. So those get 2 times the pack width. I didn't have to cram those in as much. Okay, we're almost done. So where clicked, I want to show this. So right here, before I return position, I want to print position so we can see it at the bottom here. So I'm going to rerun this. And where clicked, when you click on a screen, gives you a position. And that position is going to be based on whether you're clicking on the deck, the stack, the kitty, or the played area. And if you click anywhere else, it just returns none. So how do we do that? Well, there's actually a really simple way to do it because we have all those corners defined. You just check to see if X is in between the left and right hand side of the rectangle, and Y is in between the top and the bottom. And if that's the case, then because this is implemented as a dictionary, we just have to do return position. So we do for position in self.deck corners. So let's go back up here and look at deck corners again. Remember, deck corners is actually a dictionary, so we're going, when we do that for loop is going to say deck, stack, K row 1, K row 2, K row 3, so on. And then we're going to go in and get those corners out. So position here is going to be deck, stack, K row 1, K row 2, K row 3, up to played row. So when I click here, why is nothing happening? Did I not run this again? I must not be calling where clicked anywhere. Let's see, is that not? Oh, well, that was silly of me. I don't have where clicked bound to the canvas, so that's going to have to be in the next video. I'll show you how that works again. Change color at this point, we're just doing a pass. We'll implement that later in another video. I guess this video is getting long enough, so that's it for this one. We'll see you in the next video.